Right, let's continue with diode applications. We are going to talk about clipper. All right, so what is clipper? It's basically a circuit for the diode to use diode to clip away portion of an input signal. Let's say input signal is like this, and then we want to clip, let's say, this part. Okay, so we want the output to be like, let's say, something like that. Okay, so we clip away the bottom part. So this is what it means we use diode as clippers. Right. There are two categories. We have diode in series and in parallel. Okay, the simplest clipper that you can see is the half-wave rectifier, which it clips only the negative parts. Okay, we throw out this part, so the output will become like that. So this is half-wave rectifier. Basically, this is a diode clipping option, clipping action. All right, so let's look into series clippers. Series clippers can be used to clip off either you want a positive or negative region. There are no boundaries of the type of signal, which means not only talking about sinusoidal signals, but we can also look into square wave signal or triangular wave signal. So if you can see here, this is square wave. We clip the negative parts and the output only on the positive part. Same as the triangular wave. If we clip the negative part, then we only have the positive part in the output. Right. Let's see diode as in series clipper. Series. What it means by series? It's the output is in series with the input. Okay? In this case, for example, this is the input voltage. This is the output voltage. Output voltage here is basically here across the R. So this is the output voltage. It's actually in series, in series with this. Okay, both ways, right? So if it's the supply is positive or negative, depends on the arrow depends on the supply whether it's positive or negative. In this case, negative at the top, positive at the bottom, so the arrow looks like that. So in this case, we are clipping the top part. Okay, we're clipping the positive part. So the output only we have the negative parts here. The only negative signal is going through the output. Right. What's going on here? Okay, the clipper usually we can use DC supply to manipulate or to clip certain portion of the area. For example, if you want to clip here, so you have to use a DC voltage. All right. So the difference, if you want to clip on top, you have to use DC supply. You just need to manipulate the direction. Okay, like this, for example, plus over here, negative over there, or the other way around. You can have negative here, plus over there. So this DC supply will determine the operation of the diode. Okay. In this case, a series clipper with DC supply, you assume ideal diode, but in your assessment, test or exams, you need to check whether the questions are referring to ideal diode or it's given either assume silicon diode or germanium or whatever. So if it's assumed silicon diode, it's 0.7 volts. So for easier calculation, to simplify your calculation, you may first use ideal diode, but in this subject, I would like to stress on the use of the actual or silicon diode, because you're going to do the lab exercise using silicon diode, and then you need to also verify with the calculation. So um, make sure you know how to use if we are talking about the actual silicon diode. Any positive voltage of supply will try to turn on the diode, but added DC supply on the negative part or opposed to the applied voltage will try to keep the diode in the off state. Any supply greater than DC supply will turn on the diode and establish conduction through load. Okay, let's look at this example. When we analyze this clipper, we need to know when is the transition condition. What it means by transition, meaning at the point where the diode starts to turn on or turn off or whatever. Okay, so in this case, when the diode starts to turn on, meaning the diode is short-circuited or forward bias. So which point the diode will be forward biased? In this case, there is a voltage negative to it, meaning opposing the diode direction or making it reverse bias. So let's say this is 0.7 volt. Just take a random number, 0.7 volts. So if it's 0.7 volts, meaning if the current flowing this direction, um, until the voltage here reaches 0.7 volts, then the diode is turned on for ideal diode. If it's actual diode or silicon diode, then you have to wait for 1.4 volts so that the circuit will start to flow. So if that's the case, the cutoff, the point where positive 1.4 volts will only make the diode turns on or starts conducting currents, and this will make the output will have some values. So in this case, at this point, for example, 1.4 volts, only the output will on. Okay, so if you draw an output graph, this part will only on in the output. Okay, the timing here should be the same as this. Right, so the output will look like this if it's having this voltage supply 0.7 volt. Let's say if you have something like 1 volt here. So to turn on the diode, the supply input will have to have at least 1.7 volts, right? So at 1.7 volts, the supply will turn on. Let's say here is 1.7. So anything at the top here, okay, the supply is on, the diode is on, so the output, okay, the current will flow like that. So the output will see a current flow. So this portion on the positive side, okay, will be appeared in the output graph. Right, let's look into KVL or the analysis using circuit analysis. Let's use Kirchhoff voltage law in this case. VI minus V minus VD, okay? VI minus V minus VD, okay? So the output will be like that, minus V out equals to 0. So if you're looking for VD at the transition point, so this VD is 0, or at least 0. Okay, let's use the actual diode. So this is 0.7 volts. So V out equals to V in minus the V minus 0.7 volts. Okay, so this is the voltage output at the point where it is started to conduct. Okay, where the diode starts to conduct. So this is the transition time. All right, to find the output voltage, the maximum maximum output voltage. So maximum voltage Vm is, what is your maximum V in? Sorry, it's actually we're looking for V out. V in is Vm minus let's say this V. What's the value of V here? So let's say we have a 2 volt battery minus 0.7. So V maximum, let's say this is 10 volt. So 10 minus 2 minus 0.7. So what we have is 7.3 volts V out.